Good morning. Today I will be tackling about the formation processes of mineral deposits. Before we dive into the formation processes, let's first understand what mineral deposits are. A mineral deposit is a naturally occurring concentration of minerals in the Earth's crust that is economically valuable and can be extracted for use. These deposits form over millions of years through a variety of geological processes and are the foundation of the mining and mineral industries. They provide essential resources such as metals like gold, copper, and iron, and non-metals like limestone, clay, and salt. The way these deposits form determines where and how we find them. There are 6 primary processes through which mineral deposits form: magmatic, hydrothermal, sedimentary, metamorphic, placer, and weathering. Let's look at each one in detail. Magmatic processes begin with magma from deep inside the earth. As magma cools, heavier elements settle and crystallize. This leads to the formation of deposits like chromite, magnetite, platinum, and nickel, often concentrated in layered igneous intrusions. Magmatic processes involve the formation of mineral deposits directly from molten rock or magma deep beneath the Earth's surface. As the magma cools and crystallizes, heavier elements like chromium, platinum, and nickel separate and settle due to gravity, forming layered intrusions. During cooling, volatile gases and fluids rich in metals are also released. These fluids rise and concentrate within fractures or porous zones, leading to the accumulation of valuable minerals like chromite, magnetite, or sulfide ores in specific zones. In the diagram, you can see how these minerals crystallize near or above the magma chamber, forming deposits with volcanic rock layers. This process is often associated with large igneous intrusions such as Bushveld complexes and is a major source of strategic metals. Hydrothermal processes involve the movement of hot metal-rich fluids through fractures in rocks. As these fluids cool, they deposit valuable minerals like gold, silver, and copper in veins and cavities. These deposits often occur in volcanic or tectonic regions. Hydrothermal processes form mineral deposits through the circulation of hot, mineral-rich water within the Earth's crust. In the illustration, seawater infiltrates the ground and is heated by a nearby magma chamber. This hot fluid then dissolves metals like gold, silver, copper, and lead from the surrounding rocks. As the fluid moves upward through cracks and faults, it begins to cool. When it reaches cooler zones near the surface, the dissolved metals precipitate out of the solution, forming vein-type or disseminated ore deposits. The repeated movement of fluids in this convection system concentrates metals in specific zones. These deposits are often found near volcanic arcs or mid-ocean ridges and are some of the world's most productive sources of precious and base metals. Sedimentary processes occur when minerals are transported by water or wind and settle in layers. Over millions of years, pressure compacts these sediments into rock. This forms deposits such as bauxite, iron ores, limestone, and gypsum. Sedimentary rocks form through a series of steps starting with weathering and erosion of pre-existing rocks. As shown in the diagram, weathering breaks rocks down into smaller particles. These particles are then transported by natural forces like wind, water, and ice. Once these particles reach bodies of water, they settle through deposition, forming layers of sediment. Over time, these layers become compacted and cemented, hardening into sedimentary rocks. This process results in the creation of rocks like sandstone, shale, and limestone. These rocks often contain valuable resources, and the cycle continues as sediments are constantly moved, deposited, and transformed. When rocks are buried deep underground, they are subjected to intense heat and pressure. This causes them to change in texture and composition, forming metamorphic rocks. Valuable minerals like graphite, talc, and garnet can form this way. Metamorphic processes form mineral deposits through the transformation of existing rocks under intense heat and pressure without melting them. As shown in the diagram, igneous and sedimentary rocks can become metamorphic rocks when buried deep within the Earth's crust and subjected to these extreme conditions. This transformation changes the rock's mineral composition and structure, often leading to the formation of economically important minerals like garnet, talc, graphite, asbestos, and even marble from limestone. Sometimes, metal-bearing fluids from nearby magma can also move through these rocks, further altering them and concentrating valuable elements like tungsten, zinc, and lead. The diagram illustrates this process through arrows moving from sedimentary and igneous rocks towards the metamorphic rock box, triggered by heat and pressure. These rocks can eventually melt and re-enter the cycle, forming magma again. Metamorphic processes are especially common near mountain building zones where tectonic forces push rocks deep into the crust, making this a key contributor to Earth's dynamic rock and mineral cycle. Placer deposits form when weathered minerals are carried by rivers or streams. Because heavier metals like gold and diamonds sink faster, they collect in stream beds or along river banks. These are some of the easiest deposits to mine. Placer deposits are formed through the weathering and erosion of minerals, which break down into smaller particles over time. As shown in the diagram, the process begins in the zone of weathering where ore minerals are exposed to natural forces like wind and water. These particles are then carried by mass wasting like landslides, gravity-driven transport into streams. The stream then transports these particles along its path where they eventually settle in specific areas, forming placer deposits. These deposits are concentrated by the action of water, with heavier minerals sinking to the bottom and accumulating in stream bed. Placer deposits are important sources of minerals like gold, tin, and platinum, which are often extracted by panning or dredging from the water. This natural sourcing of minerals due to their density is what makes placer deposits an economic source of valuable materials. Weathering processes break down rocks at the Earth's surface through wind, rain, and temperature changes. These can lead to the concentration of minerals near the surface like bauxite and kaolin through chemical leaching and residual enrichment. Weathering is the process by which rocks are broken down into smaller particles influenced by physical, chemical, and biological factors. As shown in the diagram, weathering begins with the alteration of igneous, sedimentary, or metamorphic rocks, which are affected by different types of forces. First is the physical weathering. This involves mechanical breakdown where rocks are physically fractured into smaller pieces without changing their chemical composition. The increase in surface area enhances further weathering. Next is the chemical weathering. Here, the rock's minerals chemically react with substances like water and air, leading to the changes in the rock's composition. Next is we have the biological weathering. This occurs due to the actions of living organisms. For example, plant roots may penetrate rocks, causing them to crack and break apart. The weathering processes result in altered rock that is then either transformed into soil or carried away by erosion or mass wasting, further contributing to the natural cycle of rock breakdown and soil formation. To summarize, mineral deposits form through different processes, each with unique conditions and outcomes. Magmatic, hydrothermal, and other processes lead to the formation of valuable materials or minerals used in various industries. Understanding these processes is key to locating and extracting these resources. Thank you for your attention. I hope this presentation helped clarify the processes through which mineral deposits form.